Hi guys. So in the previous video, we have seen the intro to testing package in Golang. We have seen that the testing.T package of Golang has many functions. So today in this video, we will explore those functions. So before exploring, we have to first understand what this function is actually doing. So this function is taking one input as a parameter, and based on that input it is returning some string. So if the number is divisible by 3, then it is returning 3. If it is divisible by 5, then returning 5. If it is divisible by 2, then returning 2. Otherwise it is returning an invalid number. So in order to write a unit test for this function, we have to satisfy certain conditions. So the first condition is that we have to create a file whose name ends with underscore test.go. So let's create that. So after creating the file, we have to write the package. Now the second condition is the file should be in the same package where our main function is present. So here our function is present in package unit test. We can name it anything. So we have to enter that package. Now the third condition is we have to create a function whose name will start with test, and after that we can write any name, but usually we write the name of the function we are testing after that. So let's define that function, and our function was check divisibility. So let's copy that. And the next condition is that this function should take a unique parameter of type testing.T. So we have to import the testing package here. So for that we can press Ctrl plus S and it will automatically import that package. So now once we have satisfied all the conditions, now what we will do is that we will call that function and pass it some examples and see whether the function is returning correct result as per our expectation. So let's take an example in which we will take input as 5, and we know that for 5 our function will return in response 5 string. So for this our want will be a string with name 5, and what we got, we will pass this input to our function check divisibility. So here we will pass our input. So after passing the input, we will check whether our want is equal. If it is not equals to got, then we will log error. So for logging error, our testing.T package provide one function known as error function. So there are two variations of this function. First one is error and second one is errorf. So there is a minute difference. Like with error function, we can only print statements like whatever we want to log, but we cannot add some extra information to it, like for which input it has given wrong answer and what it has written actually. So let's use first of all error function. So with t.error we will log error. Like here we will write incorrect response. Now let's run this function and see what's happened. So in order to run this test function, we can use two methods. First of all, the first method is provided by the Go. We can simply click on this run test and it will run the test. So let's run this test. So it has given like all tests has passed successfully. Now the second method is we can use our go test command. So for running this command, we have to go to the folder in which our unit test is present. So our unit test is present in the folder unit testing. So we will go to that folder. I am currently in that folder and I will run the command go test. So what it will do is that it will run all the test functions which are present in that particular directory. So currently in a directory only one function is present. So it will run this function. So let's run this command and you will see it has passed successfully. Now let's change our bond. Let's suppose our bond for it will be 3. So for this case it will log this error. So let's run again this command go test. So now it has logged, the test case has failed and it has logged the file and the log response is which is incorrect response. Now in the response we are not getting like for which input we are getting incorrect response. So for that we will use errorf function and here we will use some formatting verbs like percentage s and here we will print like for what input and here we will write input and here we will write our want as percentage. So here it is string and here it is input is integer, so we will write percentage d and here got percentage s. So here we will write input or want and got. So now if we run this function again go test, so right now it has printed like incorrect response for input 5 and we got 3, but like we want 3 but we got 5 here. So this is how we can use a error function and error function. Now let's see another function which are log and logf function. So these are, as the name suggests, these are used for logging. Like for extra information we have to provide. Let's suppose I can log here t dot log. Here we can write running test, but here we cannot specify extra information. So for that we will use logf function. And here running test for input and here we will write percentage d and here we will write input. Now if we run using go test command, it is specified our log as well. So it has also written the line and the file it has run. So running test for input 5 and got incorrect response. So let's take another example in which we will take input 2 and pass to our function. So let's take the input to be as 6. So in this case our want is 3 and let's call that function and store the response in got2 and we have changed the input to 2 and in this case we will repeat the same, like if want is not equals to got. We will log here the input and here also we will log like for which input we are running the test. Now let's run this test function with the go test command. So as you can see that it has written in the response some logs. So it has written the log for our first input 5 and the incorrect response, and for our second input, so I think in the second function we have passed input is 6, so it should give a correct, but let's see what has happened here. Okay, so in the second, this is the R case. So in the second, it has not written failed, but the overall test has failed. It has written here. So now you can see, like if we have to test multiple test cases, then we cannot simply declare input and call, because we are repeating same line of code again and again. As you can see that I have repeated this line of code and this line of code two times. So let's suppose if I want, if my function is something like that, like in that almost 10-15 cases can be designed. In that case, I cannot run such a long function. So for that case, table driven testing is introduced. In that, what we do is that we'll store all our input want in some array of structs, and we loop over those struct, and for each case we run our test function. So we will see how to write table driven test in Golang with the testing.T package. So for this, let's create a second function, and so the function should begin with test as prefix, and we can write here check divisibility table driven. And as per the condition, we should take testing.T parameter. Now let's create one struct. Let's name this struct as test cases. And in this struct, first of all, we will define the name as string, which will define for for which case we have introduced this test case, and we will pass here our input and our want. So in this case, our input is int and our want is string. Now let's so our first input, let's take from the above, in that our name was 5. Our input, our name was, let's give it a name input 5, and our input is 5 here, and our want is 5. For our second case, our name is input 6. So as you can see, like I can define multiple test cases here without repeating a lot of repeated code. And here my input is 6 and want is 3. Let's take another example. So in this case, we will pass input as 2. So once we have designed our test cases, we can iterate through the test cases. For test range test cases, what we will do is that we will use a t.run package. In this, we will pass our test.name. So this t.run package takes, as you can see here, the first parameter is the name and the second is the function. So in this we will pass our function which will take some parameter t. So now, like when we are iterating through the test cases, for each test case we have got the name, input and want. So here we will call our function with got is equals to check divisibility, and in this we will pass test dot input, and if our got is not equals to test dot want, then in that case we will log error using t dot errorf. And here you will write incorrect output, and we will copy the same thing here. And got. Also we can log here like something running test, and here we will log running test completed. Now let's run this function using the command given by go. So first of all, test with this run test command. So it will only run this function particular, and it is saying that all test case has passed successfully. Now let's run using go test command. So with go test command, it will run all the functions which are present in this file. So it has run the first function as well and the second function as well. So we have to check for the second function. We can see when we have run go test command, it has only show logs of check divisibility function, and it has not show logs of test check divisibility table driven function. So there is some limitation of go test command. It will only show logs for the test case which has failed. Otherwise it will show okay as the response. So for this you can see that if we change this to 5, then our this test case will run successfully. Then if we run go test command, then it is simply returning pass okay. It is not printing the logs which we have printed here. So for more verbose output, we can use go test with -b flag. In this case, it will print all the logs present in the code. So now if we let's again change this to 3. Now if we run this, you will see like for the first function, it has written the log running test 5 incorrect response, and running test for input 6 for past as well it has logged, and like it is here saying that fail test check divisibility, and it has run test check divisibility table driven, and it has run all the inputs, and it is also logged running test completed, running test for each input, and it is saying that all the test cases have been passed for this function. So now as you can see, like these are the two test cases. They are currently running sequentially. For the first function test check divisibility, we can run these functions in parallel as well. So how can we run these functions in parallel? For that we have to use the parallel function given by testing.T-Type package. So in that we have to simply use t.parallel function in the test case. So how we can use it? For that we will have to use t.run command. So we will encapsulate this function in t.run, And here, as a syntax of run, it will first take the name or title of the test case. So like let's write the title as input 5 and pass the function here with testing.D parameter, and here we will write t.parallel. Now we will simply copy this logic here. Same thing for below. Let's copy this, and here our input is 6. Also we have to also specify our want and call function as well. So now these are our two test cases which will be running in parallel. So when we run this function, it will run all these in parallel. So currently, as you can see, like the functions are running sequentially. Now when we run go test dash b, so now you can see that it has started running test check divisibility function, and it has started running our first input 5, and it has paused running that input, and it has started with input 6, and it has paused this as well, and it is continuing with in parallel all the inputs. So this is how we can execute our test cases in parallel with t.parallel function. So in Go, there is one environment called Go max procs, so which defines how many tests we can run in parallel at one time. And by default, this number is equal to the number of CPUs. Now let's discuss another function which is called skip function. So this function is used if we want to skip certain test, or if we want that our test case should run fastly, so that we are skipping some tests which are not required. So for this we can use a t.skip function. So we can call that. So for calling that, what we can do is that either we can simply call here t.skip. So in this way it will skip this entire function running. Like we cannot run all the test cases. So let's try this. So go test dash b, and as you can see that it has skipped running this test entirely. But we cannot change every time manually. So for this, Golang has provided with go test command a flag called test.short, which is used when we want our test cases to run faster and have to skip certain test cases. So for this, we can use if testing.short, then only it will skip our test. And this one is true when we pass with our go test the flag testing.short or test.short. So let's run with the flag test.short. So we will write go test dash v dash test.short. Now you can see that it has skipped this function. Now let's call without passing that flag. So now you can see in this case it has run this our test function. So but we cannot skip simply all the test cases. So we can pass it with certain test cases, like here if we want to call this function, or for table driven test we can simply include it here, so it will skip these functions. Or for some certain inputs we want to skip, we can use we can specify in the condition that as well. So this is how we are using testing t.skip function. Now let's see another kind of function known as cleanup function. So this function is basically used for cleaning up resources and performing cleaning up operations after a test has completed. It ensures that all the resources are properly released. So let's see how we can use cleanup function. So as we know that this function is executed at the end. So let's it is no matter like where we call this function. So let's call t.cleanup, and this function will take one function as a parameter, and in this let's print something or log something, t.logf. So here we will simply print test completed, or we can write running test completed for input percentage d, and here we will simply pass our t.input. Now if we run this function, go test dash v, so you can see like for each test in our table driven test it has printed this. So whatever the things we want our function to do after our test is running completed successfully, we can place it here. Now let's see another function which is known as fatalf function. So this function is similar to error function and log function, but there is one difference. It will stop the execution of the test as soon as they are executed. So let's see. Let's suppose if we want to stop the execution of the code whenever our test fails. So instead of using errorf, we will use fatalf. So now what it will do is that it will stop the execution of the code whenever this will fail. So I have changed the want for this as 3. So for this it is wrong. So let's correct this, and for this it will be 2, and for this we will change to let's 5. Now let's run the code. So you can see for input 5 it has printed running test completed, and running test completed for input 5. For input 6 it has printed running test, then it has printed incorrect response. After that it has not printed this one running test completed, because it after that it continues to the next function. So you can see for the last input it has printed all the 3 logs which we have added. So in this way we can use fatalf whenever we want to stop the execution of the code. Let's see another kind of function which is called tempdir. So this function is basically used to create a temporary directory which can be used to create and store files and other resources that are needed in our test. It is particularly useful when you want to isolate and control the environment of test without affecting the actual file system. So in order to use this, we will first of all here declare one tempdir variable, and we will call t dot tempdir function, and let's create one temporary directory. So let's create one file and error equals to os dot create tempdir plus tempfile.txt, and if there is error, then we will use t.fatal function, and we will log the error failed to create file, and we will defer temp file dot close. Now let's run this test. Let's print as well temp, but it prints all lock. It is not printing, so we can do something like this: percentage we end up in this. Now let's run this function. So it has created the file successfully because it has not stopped the execution, and it has also printed the file, and every time it is creating new file, so you can see the new address. So these are the functions which are present in our testing package. Thank you.